potentially, but connected. Oops. Connected to the internet. And then we have a bunch of physical devices connected to the internet. Now, depending on the source you go, you can say 75 billion in the next few years. Other sources claim more, other less, but nevertheless, there's billions and billions of devices. The question is, are these two separate cyberspaces? Right? One for the humans and one for the things, smart things. Now, clearly, that's not the case. So these two worlds, the physical smart devices and the humans, overlap and meet each other in cyberspace, and not just physically without any kind of digital interaction. And this is really a combined, unified digital realm. And then, even though it's a unified digital realm, do we still have these separate relationships? Do we have just humans to cyberspace, in a silo, separated from the relationship that physical devices have through cyberspace? And the answer is no. It's all become a one single unified digital realm. So when we get on there, we are no longer just siloing ourselves to interaction with digital entities within cyberspace, the apps. We are also interacting through that cyberspace to physical devices, like your Fitbit, for example, right? Or you're remotely controlling your home security system or your home cameras or doors or whatever. So the cyberspace has become both a medium for connectivity between us and physical devices, but also kind of a home where everybody lives and cohabitates. So we have this convergence of the three things: humans, physical things, and cyberspace. And of course, AI is all part of that, and we'll get into that. Of course, all of this is kind of newish, and it requires elevated digital literacy to be able to leverage all of the benefits and mitigate some of the concerns around this. Okay, so that's kind of the big picture, but let's dive a little bit further into the Internet of Things. As I already mentioned, the Internet of Things consists of things on the right, the internet in the middle for connectivity, and then cloud to store the data, manage data, and analyze it. This is like a big picture or a big iteration deployment of the Internet of Things. And those devices connected into the internet use a variety of different connectivity technologies, anywhere from wired power over Ethernet or Wi-Fi or Zigbee for local wireless, or 3G, 4G, 5G, kind of the latest thing, which was actually designed for IoT as well, and then long-range wireless communication. And we also have something called edge and fog computing, which is kind of like the cloud. Cloud is up there. It looks at a wide area, but edge and fog, call it fog, it's close to the ground, real close to where the devices are, to provide some real-time computing and interaction. So this is kind of a big picture, maybe a city, maybe a big manufacturing plant, maybe a national transportation system based on IoT. And if you look at the high picture, high view again, you can see that it consists of physical devices, the network, and analytics and control, right? Now we can take that and scale it down to something more personal, like the Internet of Things that's occurring in your smart home with a smart thermostat. And so that smart thermostat is connected to a bunch of devices, connected over local wireless, and the analytics is shared perhaps between the actual thermostat and maybe an app that you have on your phone, connected over Wi-Fi. And again, you look at kind of the higher level picture, you have devices, You have the network, and you have analytics and applications, right? So that's kind of Internet 1.02. And we could go on and on, give you a bunch of examples. An example of Internet 1.03, some version of like a small manufacturing plant, or 1.4, an agriculture, smart agriculture application. Whatever the case may be, they all have this similar architecture, right? So basically, in a nutshell, you have things and devices that are connected, have connectivity through the internet primarily, and they have somewhere they have data analytics of the data that those devices generate and control of those devices. So this is at a 30,000-foot level, the proverbial 30,000-foot level. This is, in a nutshell, what the Internet of Things architecture is. However, architecture is just an architecture. It's the bits and pieces to create a solution. It's not kind of the end goal, or that's not where the value is. To really appreciate the IoT space, it has more than just this one dimension. So I think of it more as a space. And as a space, you have to consider how that architecture is applied, and that's in the verticals or the sectors, if you will, or applications. And when I talk about that, we're talking about smart buildings, smart cities, industrial applications, wearables, and so on. And this is where the real value is created. However, in order to be able to create that architecture and create those applications in the verticals, we have to have a set of enabling technologies and a set of disciplines that are impacted by that IoT space. And that's a different dimension, right? And there we have hardware and software innovation, new business models, security and privacy is a huge issue. And of course, it all has legal implications, socioeconomic implications, and all kinds of data governance and digital governance implications. So in order to properly think about and talk about and navigate IoT, you have to think of it as a space, which includes these dimensions, not just the architectural pieces, the bits and pieces, right? That's what it's made of, but its significance and values lies in these other two dimensions. Okay, so I talked about smart things. So in a nutshell, a thing is a physical object, generally, and it spans the digital world and the physical world. It has computing in it to make it smart. It has sensors and actuators that sense things and do physical things facing the physical world, and it has communication that faces the digital world. So if you were to abstract that, really a thing is really an entity that has a digital physical persona. It's both things at once. It's a physical thing and it's a digital thing, inseparable from each other. Here's some just some examples of things, smart things. I'm not going to go over it through, but for example, top left, you might have a bunch of sensors that monitor seniors, monitoring their fall and motion to be able to help and service them. Or you might have garden sensors to measure sunlight temperature and moisture. Or you could have smart wearables, and then autonomous vehicles are really IoT systems on wheels, computing on wheels in one sense. In another sense, they are a thing that's digital and physical, that's part of a larger IoT realm, which is the transportation infrastructure, which has its own other things and has its own other physicality, roads, gates, traffic lights, things like that, and so on. So I'll leave that at that. I could go on forever. Okay, So that's enough about IoT. So let's switch gears a little bit, talk about AI. And I'll kind of gloss over this because there's lots about AI. So of course, AI is artificial intelligence. It's really a broad term that encompasses a whole bunch of things, but in principle, it's a system that tries to mimic human abilities. And within that, you have an area called machine learning, which is a subset of AI. And machine learning trains the system to learn from data and builds models from that data. And then you use those models to be able to predict and construct, synthesize new information and new analysis of other new data coming in. And deep learning is really the structure of within the machine learning neural networks and algorithms. And so it has really sprung up lately, clearly, but it's not a new term. It was really founded or coined back in the 1950s. Just a quick, a bit more about that. When you talk about machine learning, you're talking about machine learning in two phases. One is the model creation, training, and the other one is the actual use. So very quickly, you have a model, which is a neural networks or other things. It gets a whole bunch of data, massive data coming in, and it tries to categorize, understand what it is, and it spits out some output that says it's this or that. It's a cat, it's a dog, it's a car moving down the highway. But it doesn't really know. And there's some probabilities how correct it is, but it requires an external information, humans or otherwise, to say you're correct or not correct. And then that is fed back and compared with expected output. And that adjusts the models, right? So that model isn't static. It changes continuously based on the input data and based on the expected output that model is supposed to represent. So you've created the model to some extent. Now you're going to use it. And now you'll use that data use that model on other data that now this model will analyze and tell you what it is or what the behaviors, et cetera. And it's not really just a two-phase thing that you create the model once and then you use it. Yes, you got to create the model, but then as you use it, you can update on a continuous basis that model based on new data coming in and based on the robustness of that expected output that you define. Okay, so that was AI, very high level. So question is, where is AI and machine learning used in the IoT space? The obvious answer is, well, right here, it's data analytics, right? It's used for analyzing data coming from the things, analyzing user behavior, applications use AI, and there are some vertical specific behavior that AI manages. But we would be wrong to think that is the only place for IoT, for AI. AI actually lives everywhere in the IoT architecture. In the connectivity, for example, AI is used to monitor network performance by monitoring data traffic. It manages the network, ensures that it's robust and resilient. And AI is also now moving very much into the things themselves, the devices, because microelectronics is getting more compact. You can fit more functionality on it, so you could fit more computing and specialized hardware that will implement AI. And so those things are becoming even more smarter and even more autonomous. So now, if you go back to that IoT, the big IoT space, you say, well, where is AI here? Well, we clearly said, it's in the architecture, but AI is also used in the vertical solutions on that horizontal dimension, And it's also used in various hardware, software implementations, in actually developing software, and actually developing business models. So AI is basically pervasive through that whole IoT space. And you can't really create good value out of IoT without implementing AI, using AI somewhere in that space. And so when we combine those two things, AI plus IoT, AIoT. Okay, just a little bit more before we get into use cases. You remember those yin and yang balls are the smart things, right? They have digital, physical personas. And we as humans are increasingly enveloped in an environment that includes Internet of Things and artificial intelligence. And that's creating ambient intelligence. So things that we interact with are intelligent, and it is therefore creating an ambiance of intelligent things. So now we don't just interact intelligently with other human beings, we are now starting to interact with other intelligent things, the Internet of Things. And so the line of the boundary of our communication is starting to be blurred. Whether, are we interacting with humans, or are we interacting with physical digital things? So this IoT and AI are creating a new kind of environment around us. Okay, so we'll get into some of the applications and some of the verticals. Clearly, we can't cover them all, so I'll touch on a few of them. Precision agriculture or smart agriculture is one application of AIoT. So here, by precision agriculture, we're talking about a paradigm where you apply resources, nutrients, water, pesticides, precisely on the exact plant or animal you want at the right time and in the right location. You're no longer spraying and praying a bunch of fertilizer out there and hope to get some yield out of it. And so IoT plays a role here in sensing the soil environment, temperature, moisture, sensing the biometrics of plants and animals. And it also provides automation for the farm, for the equipment, even to the extent of using robotics, which are IoT devices. And of course, AI is used here, taking all that data coming in from the farm, from the animals, from the soil, do planning and do some predictive operation to really optimize the whole operation. And of course, the impact is higher food quality, reduced food costs, better animal health, reduced greenhouse gases because you're managing your energy more precisely. That's one application of IoT. And just to bring that home, I will play this video, not all of it, just to give you a sense of what we're talking about. Okay, so you get the gist of it, right? A lot of automation, a lot of autonomy, right? You have machines going in and doing their thing without any human operator. And that actually becomes very important, not just because of the cost implications of the labor, but also because the farming community, the demographic, it's getting older and older. Like the average farmer is 60 plus, right? However, with the mechanization and AI, it enables and actually incents younger farmers to stay on the farm and participate in agriculture. Okay, so that was just one application. Clearly, AIoT has applications in smart buildings. Again, here you have sensors measuring all kinds of physical attributes, temperature, light levels, humidity, occupant motions, and location. And from that, it provides building and home automation. It controls HVAC, heating, ventilation, and AC. Controls lighting. You're able to schedule space based on people movement. And then AI is used to analyze all of this and be able to control the environment, but also be able to predict how it has to set up that building or environment to service, the predicted new people occupation, and all of this is again reducing energy utility costs and operational costs. It encourages or underpins better productivities by employees and so on. And by creating by having better energy utilization, you're cutting down on greenhouse gas emissions from buildings and homes. Another one, transportation. Here you have AI sensors, whether they are real physical sensors or machine vision, detecting traffic on roads, on trains, in the air. And from that, you're able to control the traffic signals, lights, and you're also using DSRC, which is direct short range communication, which becomes important in autonomous vehicles. And that's a communication between the car or a vehicle and other vehicles, or the curb or the traffic light. So that's another application or another technology that IoT uses to implement transportation control. And of course, it also is used to deploy vehicle electrification, charge station management, and so on. Clearly, again, I don't have to go through it. Reduced operating costs, better safety, and better environmental and sustainability. Logistics, kind of similar, but this time you're sensing the payload itself, the freight, temperature, vibration, motion of containers. You're automating loading and unloading. You're using AI and IoT to control physical access or detect tamper risks and so on. Again, the impact is operating costs, convenience, better freight delivery, more convenient, and also you are eliminating or reducing loss from mislocated or lost freight. Part of that logistics is also something called the last mile delivery, where you'll probably saw sidewalk delivery robots coming into areas. It's still very embryonic, but it's coming. And so they have sensors and navigation and computing on board and AI, some of it within the actual delivery vehicle robot, and some of it in the cloud that controls a fleet of robots. That's one application. Another one, which I haven't really seen it, but people talk about it. UPS has piloted a mechanism where instead of driving from house to house to house in neighborhoods, which chews up a lot of time, but also chews up a lot of fuel, they park the vehicle. They have the idea is you have a drone in the vehicle, and once you park the vehicle in a neighborhood, it's only the drone that would deliver packages to the final destination. Again, pilot, but I'm not sure that I've actually seen commercial implementation of this. Another application, smart grid, and that's basically ensuring being able to onload and offload electrical power intelligently from the producer of the power and the consumer of the power. That it enables you to have prosumers, implement the prosumer paradigm, meaning prosumer is producer consumer. So you might think of a house. You have a bunch of solar panels, and normally you use it, but once your batteries are charged, you may sell your production of power to the grid. And so AIoT is involved in all of this to detect where the load is needed, who's producing, and control the synchronization and the onboarding of power from sources and the use of power from the grid. Other applications are like in sustainability, and again, things like smart bins, where you have sensors in the bins that detect, how much garbage is in that bin, and so so the trucks don't have to come around just because there's a bin there at a regular basis. They only come around when there's a set of bins that have whose capacity hasn't been exhausted. They're full. And so you reduce the number of truck rolls, and you're reducing the amount of energy as a result in those truck rolls, and you're being able to recycle and reuse that material more effectively, and less of it goes to the dump. And in fact, there's also use of AI and IoT in recycling and in recycling. And here's a quick video that talks about that.
Robots don't need lunch breaks. They don't call in sick, and they don't need to go on vacation. And they can work a double shift.
This one, made by Colorado-based Amp Robotics, uses machine vision and a vacuum grabber to pick out what it can. And according to CEO Tanya Horowitz, the lease costs roughly the same as 1 or 2 workers' annual salary.
So we identify hundreds of different sort of specific types of things, but we're always teaching it new things.
And as the AI learns at this company lab how to tell pieces of plastic from sheets of paper, it also learns how to grab them.
In the future, it'll go for the flat spots and get better and better over time.
Ways we will eventually learn all million possibilities.
Well, even better, it learns to generalize. In addition to the million, it'll learn the million one that it's.
And the AI can learn the exact chemical composition of each item, allowing it to not only fingerprint which company it came from, but also sort the stuff so exactly recyclers can guarantee customers a pure form of recycled plastic or paper, not one that's mixed up with materials.
Okay, so I'm sure you get the picture here. They said something very interesting, and in that the system learns. So if you put a system out there and say, go to it, sort, but just by itself is not going to do it. They have to train it to say which piece is recyclable, which isn't, or which category of recycled piece it is. And that can only happen after a bunch of runs, and it does its trial and error, and humans tell it, whether this is correct or not. And that feedback changes the model that the AI uses. And then, after a certain level, after certain success rate is achieved, it goes and then does this thing in production. A few more things in maintenance and repair. IoT and AI is used by sensing and tracking equipment usage and performance. Telemetry provides the physical state of that piece of equipment back to the cloud. And then they also use digital twins, which we'll talk about a bit, to analyze and simulate what the potential remaining lifetime is of that piece of equipment, so they can do preventative maintenance, extend the lifetime, or do preventative maintenance to ensure there aren't any actual faults, which may then impact production capacity. And so I'll play another video about digital twins, and I'll talk a little bit more about that after you see it. Okay, so the idea is here that physical things out there have a digital representation consisting of software and data. And the way that you create that physical representation, rather than, hard coding what that device should be in digital form, it actually gets real-time data from that device. And from that real-time data, it constructs a model of that specific device. So car A will have a model, car B will have a model, but they won't be identical. They'll be very specific on this, about the situation of car A, its usage, it's how it behaves, and which is maybe different from car B. And then that model can be used to simulate on an ongoing basis what could potentially happen with that physical objects in the future if something happens, if you apply this pressure to it or turns a corner or whatever, so that you can predict in advance when a failure might occur through this continuous simulation, so that you can take it out of commission, do some maintenance, and then put it back into use. So digital twins are very key part of the industrial complex of Industry 4.0, but they won't work without the use of IoT for the sensing and the actuating and AI to analyze. Speaking of industry, I'm sure all of you have seen this, that we've gone through a number of industrial revolutions and transitions, all the way back from Industry 1.0, which was primarily coal-driven steam power, to the most recent electrification and computerization of industry. But of course, we are now living in Industry 4.0, where the Internet of Things and artificial intelligence play a key role for all the reasons that we mentioned already: sensing, monitoring, actuating, analyzing real-time data, and so on. Last but not least, IoT is definitely a big part of smart cities, and smart cities are driven by increasing world population and increasing proportion of that population living in cities, which generates pressures onto city infrastructure and management and operation, whether it's utilities or safety requirements, mobility, and so on. And the whole objective of a smart city is the interplay between these three boxes. So certainly the constituents, people living in the city, and the organizations composed of those people. the physical things in the city and the city administration and operation. And the interplay between all of those and how you do it creates a smart city with the prime objective to improve the quality of life for the citizens and minimize the cost to the administration. And so if you look at where IoT plays a role, cities composed of these physical things. Physical things could be, everyday things like benches and trees, etc., that have now digital persona because of some sensors. Could be cameras, could be vehicles, fire hydrants. And the IoT provides the ability to sense the state of that physical thing, whether it's a bench or a kiosk or traffic levels, and then impose some action on it, some actuating function. And the bottom line, the effect of all of that is clearly reduced costs for the operation and for the citizens, greater convenience, reduced energy uses and waste, and of course, reduced impact on the environment. So we're going through a whole bunch of use cases in a number of different verticals. So here's just a summary. It's not full, it's not all, it doesn't cover everything, just some of the items. You'll see that on the left, the scale of IoT and AI implementation is quite significant going forward with fairly decent growth rates, CAGR, compounded annual growth rates. It has significant economic impact from reduced operational costs, greater productivity. It has social impact as well, better quality of life, better safety, more convenience. But if read the fine print here, obviously it's very, very busy. There's some concerning things here as well, right? Both on the economic impact and social impact. And that has to do with some of the negative sides and pitfalls of AIoT, much of it coming from cybersecurity issue, privacy issues, and so on. So let's delve into that, because nothing is without risks, despite of all of the benefits. So the question is, how do you balance, and what is the balance between the benefits and the risks of AIoT? So as I mentioned, security is a big problem, and cybersecurity in particular. If you think about it, what I displayed earlier, that a thing is a piece of computing with some communication in it, and of course the physical interface. So once you have a computer, it's hackable. And not only is it hackable to cause it to malfunction, but it's hackable because you can implant malicious software on there, which can launch botnet attacks onto the rest of the world. And because you'll have billions and billions of devices, that's very significant. How do you stop that? How do you manage that? And what are some of the impacts around that? So let's take a few of those applications, verticals that we touched on. So for smart buildings, the impact of unauthorized entry through hacking is theft, damage, and safety of people and occupants. In agriculture, there's potential for sabotage or food contamination. If you're using drones to supply or deliver critical medicine or drugs remotely, you hack a drone, you can steal the drugs, or you can substitute erroneous or the wrong kind of drug. You can cause vehicle malfunction in autonomous vehicles or just plain connected vehicles, which can cause crash, injury, and death. And in smart cities, there's all kinds of implications ranging from traffic congestions, which impact safety, raises costs, and causes inconvenience, or something like street lighting shutdown, which is again, a safety issue or potential for increased crimes. So whereas cybersecurity without IoT, when we're thinking about our apps and our swipes and scrolls and clicks on our devices, that's data. And yes, you can lose money by your bank accounts being hacked. But when IoT comes into play, there's actual physical harm and jeopardy, bodily harm of your person, bodily harm of or material harm for the infrastructure. The sump pump is turned off and your house floods. So it's more than just cyber risks. It's actual physical harm that's in jeopardy. Okay, and you've probably seen here that when we're talking about all of this, we're also talking about performance, better performance of things. So let's do a kind of a Duncan experiment. You have a piece of equipment and machinery that you have in your factory or office, and you've used this machinery to do a particular task, and you've been able to enhance its performance by innovation. And over time, you've been able to raise it, but it's saturated. You can no longer enhance that performance. But along comes a new technology, alpha instead of beta, which now promises to have a much higher and exponential performance. The question is, when do you switch over from using beta to using alpha? Well, people will naturally say at the crossover or sometime later, which is correct. And so that's true in our environments. But the gotcha here is that beta, when we're talking about beta, we're talking about human intelligence, the brain, right? And over time, from 200, 300,000 years ago, when humans started to become humans, we've increased our intelligence. Our brain has grown, but it's not really growing at a huge pace. We're not acquiring intelligence at some rapid pace. And in fact, our brain volume itself is diminishing slightly. Well, alpha here is AI. Okay, so AI, as we've seen, is starting to make a big impact. And there's going to be a crossover point where AI will be able to supplant the performance of our brain. So the question is, what does all this imply? What do we do about it? What are the implications, both personal and societal? So one implication is related to future work. There's pluses and minuses. So on the plus side, IoT and AI reduces drudge work, menial repetitive work, which is a good thing. Creates an opportunity for more intellectual work. It's a good thing. You become more effective, and that's satisfying. On the minus side, because we're kind of in this transition era where AIoT is becoming good, but it still can't do everything. And the stuff that it still can't do very well is some of the fine motor manual things, like cleaning behind a barbecue grill at McDonald's or something like that. And so it creates work, perhaps that's not as satisfying for the time being. Also, clearly, it will eliminate some jobs, and it will eliminate entire professions and careers. So there are pluses and minuses on the future of work. There's also other implications. As a result of that impact on future work, we start to have loss of self-actualization. Humans do, from lost or reduced or subservient or unfulfilling work. And you start to become less relevant and maybe become excluded from society because there are fewer higher meaning jobs that we have access to. Also, there's another issue that crops up, and that's cyber autonomy. And cyber autonomy actually deals with the question of, will we be allowed to be disconnected? So if you think about today, almost everybody's connected to the internet, and a lot of services are becoming digital, and it's all very beneficial. And so it's becoming a norm. And there might come a time where people, either certain factions within society or government will say, well, for the benefit of everybody in society, because it's so much more efficient, let's make sure that everybody's connected. You're no longer allowed to be disconnected. Or worse, in some jurisdictions, that's mandated because you have an authoritarian state and they want to keep track of you at every moment and be able to assess you, how useful you are to a society, and whether to penalize you for something. So cyber autonomy becomes an important issue because not only is it an issue of you doing clicks and swipes on your smartphone, but it's also because of that ambient intelligence that I was talking about, being able to track you wherever you are without your permission, without your knowledge. Okay, before we kind of finish off here, why does AI-IoT matter in the overall socioeconomic scheme? Our economy and society is made up of a variety of ecosystems. On the economic sides, clean tech and transportation and aerospace and defense. So these are all ecosystems. They're overlapping, but siloed perhaps. And they are underpinned by a bunch of multidisciplinary activities, technological activities like semiconductor sector, hardware, software, business professionals, and so on. They underpin those individual and collective ecosystems. And of course, below that is our professional class, talent, citizens that clearly underpin all of the other activities. So where does AI-IoT sit in all of that? And AI-IoT is really kind of an interlayer between the market sectors and the technological multidisciplinary sector. So AI-IoT enables some common technological means to support the economic sectors, but it also depends on semiconductor, hardware, software sectors and disciplines to enable AI-IoT. So it's really an economic interlayer. Another way to look at it is that AI-IoT, because it's used around and it overlaps a number of ecosystems, which use similar functionality that AI-IoT ecosystem has to offer. It's really conduit between those ecosystems so that developments in one ecosystem can be reused and adapted in another one without reinventing within the siloed ecosystem. So it's really a mechanism for sharing innovation among those ecosystems. Okay, we're almost heading to the end. I don't know how much time already took. So where are we heading with all of this? Where are we humans heading? And the way that I look at it is, what impact does all of this have on our human agency? And our human agency, in my view, has three components. It's our relationships that we have, the ability to use intellect and meaning we get from that, and also the ability and the meaning we get from our labor, hands-on work. So let's take a quick kind of journey how we got here and what all of this technological development has meant to our human agency. Back in the early back at the start of the last century, 1900s, a lot of people got their agency from manual work, not to mention actual, living from it, but they got their agency from it. Of course, there were people using intellect, and they had relationships as well. But along came the computerized and automation era, where a lot of that manual work, labor work, was relegated to machinery. And so you might wonder, well, what does the dog and the man have to do with that? And that it really represents something that Warren Bennis back in the 60s said. He's a management professor. He said, the factory of the future will have only two employees, a man and a dog. The man will be there to feed the dog, and the dog will be there to keep the man from touching the equipment, right? So basically, we've gotten rid of, or at least significantly diminished the labor component of human agency. So we're left with relationships plus intellect as our main agency parameters. So now we come into this new modern era with cyberspace and cloud and AI, where intellect and using our heads predominate, but we're kind of in a similar situation as before, right? With the man and the dog, except now our intellect is starting to, the importance of our intellect is starting to wane, and we have the same situation with a man and a dog, except now the dog is a cyber dog, and he's there to make sure that man or humans don't touch the algorithms, don't touch the AI. And so we've gotten rid of diminished significantly intellect, so we're left with human agency equals primarily relationships. And so the question now is, what will be our relationships with each other, and what will be our relationship with this new intelligent, or with this new ambient intelligence? And what digital governance do we need to develop to make the best of it? I don't have a good answer, but there's certainly a trend toward a new kind of society. We've gone through several societal transitions from when we became humans. And there's an effort in Japan that's promoting this idea of society 5.0. And just to put things in context, if you map industry 1.1 through 4, it's kind of in this era here. It's in society 3.0 and society 4.0, where it was dominated by industrial and information society. But the new society coming on board, they claim, is society 5.0. And if you look at carefully, what they say is that the way that we produce things, our productive approach is not hunter-gatherer, which is on the left extreme. It's by merging cyberspace and physical space, right? And that the city ideals where we live is not just viability, just survival, it's humanity. And if you go back to what I said, the cyberspace and physical space, that's really like AI and IoT. And so we have a convergence of IoT and AI with humanity. And hence that trilogy that I talked about. You have cyberspace, physical things, and humans merging into one paradigm with AI playing a prominent role there. And so where's our governance around all of this? How do we achieve society 5.0? But never mind that, how do we just achieve mitigating some of the negative effects? And this is where we have a problem. If you look at how governance policies have been done in the past, it usually goes like this. You have some technological epoch, and after some time, we realize we need some standards or policy or regulation. So for example, the steam engine allowed us to go faster, and that created pressure to create standard time zones, for example. Electricity came on board. There were a number of schemes, DC, AC, this type of plug, that type of plug, this type of light bulb socket or that. So after a while, it became very important that we should standardize so that we can actually create new innovation on top of those standards and, regulations in terms of safety and so on. So problem is that governance goes at a particular slow space, right? The way that our policymakers work. They have their own mindset and the way of working. However, technological innovation, technological advancement is going much faster. So we're faced with this increasing diagonality or gap between the technology coming on board and our response from a governance perspective. And I'm afraid to say that this digital physical transformation and regulation around AI and IoT is really lagging the pace at which this technology is evolving. IoT has been around for a long time. There are regulations and standards, but it's not anywhere at a level it should be. And AI just took us completely off guard, right? Oh, AI is coming, AI is coming, AI is coming, and boom, it's here. And so we're now stuck to accelerate the regulations around that, contrary to what some people think and want to do is to slow down AI. You're not going to do that. So we are, in my view, in serious trouble with this gap between the technology and governance. So in summary, I'd just like to say that AI-IoT is here and now. It's really a fusion between AI, IoT, Internet of Things, artificial intelligence, Internet of Things. That creates an ambient intelligence around us. The things that we deal with are no longer dumb things that we handle physically, just physically, but also we interact intelligently with them through the medium of the internet and through the liaisonship, if you will, through AIoT. It's very important to the economy. It underpins multiple sectors and transforms the economy and increases productivity. And it clearly does enhance our human experience in many ways and does serve the societal interest. But I'm sure you guessed it by now, and no surprise, it poses some significant risks as well, not just digital, but also physical risks, both for humans and our bodily risks, also societal risk and economic risks. And we have to deal with this widening technology to governance gap. And really the bottom line is that AIoT is really the mechanism which enables physical world digitalization, and consequently this notion of digital physical transformation, which is not separable from the broader digital transformation that we're undergoing. You can no longer separate a digital transformation here that's involving just humans and cyberspace from the digital transformation that's happening between physical and cyberspace. They're all intertwined. They're all one. They're all one big concern and imperative to do transformation. For other resources, please check out AI-IoT Canada. We're a nonprofit organization that is creating an AI-IoT ecosystem for economic growth and societal good. I also do a podcast on the Internet of Things called IoT North. And my partner and I have a white paper on this topic, similar topic. And we also provide a workshop in this space as well. So that's it. Thank you for listening to me. Certainly looking forward to the discussion that will follow.
Well, Walter, thank you very much for this, I found very stimulating presentation, and in particular, the latter slides from 45 towards the end, because I've been writing op-eds on exactly the same themes on a broader context in terms of the general nefarious uses of AI. And in fact, one of the op-eds is going to be published before the end of this month at the Center for International Governance Innovation. And it is exactly what you were talking about just a few moments ago in regard to how AI could ultimately perhaps help dumb us down.
Yes.
We become so dependent on it as we lose our agency. And so this is a really, I think, a very hot topic that needs more social science applied to it.
Yes.
But and in that context, I would like to ask a question as sort of the chair and then let others flow. But as you know, and others I'm sure, the Internet of Things came from what we used to call SCADA or SCADA, which stood for Supervisory Control Data Acquisition Systems. And in the early days, and the early days were like 20 years ago, these were all basically proprietary systems that were produced by various companies. And so if you bought into that particular SCADA system, you were locked in.
Yes.
Because it was not compatible. There's a standards issue that Walter raised. But at the same time, it was much safer, as it wasn't hackable in the same way that what happened when suddenly the internet came along and all the SCADA people made everything operate on the internet without thinking about the cybersecurity context of it. So my question then is how has cybersecurity got back into the AIoT world, or is it yet there?
We're struggling, right, in that space. I think in here, so I'll try to be closer to the mic. There's definitely a problem with cybersecurity in IoT and AI. If you look at IoT and you look at any survey about IoT and what are you using it for, what are your problems, etc., what prevents you from using it, guess what? Cybersecurity is top of the list all the time. And I think it's there because of the same reason that we had and still have the plain vanilla internet cybersecurity, right? Everybody's gung-ho to go out there, in the internet space, do their apps, do their monitoring of people's activity, and we'll deal with that later, right? And, to some people's interest, it's not even important to do that. In fact, they would want lax security. So the pressure to just put product out there and use it was there for the internet, and it's here for the Internet of Things. People that producers create products and want to get it out, want to commercialize it, and want to get revenue out of it, monetize it, and the cybersecurity aspect is an afterthought. And so what we need to do, and there are now people doing that, proposing that, is that you have to build in security from the start.
Yeah.
In the design cycle, right? You have to anticipate what it could be, what attacks you might have, and how, if they do happen, you're going to address them. And so product from design to also the development infrastructure as well. Make sure your software development environment is also secure. And then once you deploy, there has to be a way for continually updating, because it's all software, right? IoT, be able to in real time update the software to mitigate or get rid of any kind of virus or mal software. So it is a problem. People are aware of it, but it's a struggle. And I think the way to reduce it is just more awareness by the consumer, for example. The consumers are pretty dumb about this. Now, I don't want to make them like dumb people, but they're not knowledgeable, right? And they buy a device, put it into their network, whatever the defaults are, they just use it, right? And people, hackers, and know the default passwords, for example, and they can go in and statistically affect lots of devices. So there are now laws coming into play. California is one, and others. UK is making some strides in this, where there are regulations that prevent or don't allow product to be shipped with default passwords and force the consumer to actually do assign their own password. It's a small step, but there are other things done as well.
Perhaps a supplementary to this discussion that we're having is the role of AI agents. Have you considered the role of AI agents as becoming kind of specialized packages inside of an IoT system, where the AI agent is in effect a specialized large language model that's customized to the application of the IoT?
I really don't know too much about that, but AI is coming. Okay, so AI, more specifically machine learning, I would say, because that big picture that I showed, it's AI big space, more machine learning. It is coming into play in the device itself, because, like I said, the microelectronics are becoming more compact and more sophisticated, but more importantly, the computing architectures, the GPUs, and the various AI-specific hardware is being able to be fit into devices. So, when you're talking about agents, the agents are presumably communicating with the big AI or some master coordinator AI in the cloud. And so the microelectronics are enabling that. And that's certainly a valid architecture, just like, it used to be master slave server kind of architecture, without AI. So I would imagine that's going to be a scenario that will be deployed. And, the agents to some extent will have autonomy because they will become more intelligent, and they will not rely on direct control from the cloud.
Well, as a matter of fact, I might share with all of you a story I got from Jeffrey Hinton about a week ago in a webinar. I was watching him give an interview with a colleague. And you talked about this, Walter, and it was on the assembly line. And you had the manual assembly. Well, of course, that depends on vision. So we now have machines that have vision, artificial intelligence vision. So they know what a part looks like. Whether it's upside down or sideways, they can recognize it. They know what it is. So this was a Jeffrey's situation as he described it. And a belt would be normally moving, but in this case it's stationary, and it has a pile of parts on it. And the robot has been trained on every one of these parts, and it knows how to put it together. So it takes the parts and puts it together, just like Lego. But then the experiment, they took all of the parts and put them in a pile, and put the pile in front of the robot. And the robot didn't know what to do. It paused, and then suddenly it took its arm and spread the pieces all over the table. It was never programmed to do that. This is a sign of sentience.
Yeah, so we're not there yet, right? And right now, everybody has has this vision of the panacea of general AI, right? Where the AI knows everything. But right now, in most cases, it's very specifically tailored to a realm of application. And once you're presented with something that it hasn't been trained on, it's obviously lost. So
This was a profound, experiment in the sense that the machine did not have any training on to the idea to spread the pieces around. I mean, that's what a child would do. You're giving them pile of toy, a pile of pieces, and they would probably do the same thing.
Yep. And when you think about AI, it's really exactly like that. It's like a child or a dog, it gets born, it has some certain structure in its brain that it allows it to learn, but until you present it with information, visual and correction, etc., it doesn't learn, right? You have to provide that training. Same with the dog.
Well, it's not only just learning, it's also practicing what it's learned. I mean, that's also what we do. I mean, as humans, we've learned over time, but we practice what we learn, and we use what we've learned to extend to learn other things through our curiosity. No, we haven't reached that stage in machines yet, but it's certainly starting to be closer than I've ever expected. And I've certainly been a watcher of this field for a long time. Listen, Eleanor had to leave because she was getting exasperated by the heat. But she made a question, or at least a comment, and I'd just like to read it and get your response. She said, and this is in regard to you, she says, you say that analytics make possible lower pollution. But her comment is, I suspect pollution will be higher because there will be more of everything.
I think the more of everything is a separate issue. I think the more of everything is a societal population issue. Right?
Yes,
I mean, AI by itself is not going to create more things. Yes, AI does have a environmental footprint because of the compute power and the energy it uses, for sure, right? And hopefully that'll come down as we progress with technology, and the benefits that it has in terms of better efficiency and better traffic routing or whatever, it'll counterbalance that usage. I don't know. But in terms of, I'm not exact. I guess I'd have to ask her what she means by more of everything.
Yeah, well, I think I interpret it, because she's not here now, but I interpret it to mean just more of, it's just like business as usual, consume, so we keep having more of everything.
Yeah.
So yes, the unit consumption of energy per, or the consumption of energy per unit might go down, but the fact is there's more units.
Yeah, and the more units
yeah.
My view is all relates back to population.
So anyone else want to ask a question? I've got a ton of questions, but I see there's certainly some people here that may want to ask some question or comment.